It is said that a typical ICE engine car has 2000 moving parts, and in spite of all that complexity, as a driver, when you drive a car, all that you have to be aware of are three four things like steering wheel, the gear shift, the gas pedal, the brake, and the clutch. With these 4 5 knobs, if you say, you can drive a car very comfortably and with a lot of reliability and safe, and taking care of the safety, right? And that's simply amazing that that you are able to do that. And this is the example I want to use to come to the idea of abstraction. What is happening here in the case of car is a large, quite big, complicated system has been abstracted away behind a very simple interface of 4 or 5 things. In fact, if you drive an automatic car like I do, you only have to worry about steering wheel, gas pedal, and the brake. Only three things. Even the gear shift is taken care by the automatic gear shift system. Coming to software engineering, because I am a software engineer, the idea of abstraction is everywhere. So just to define the abstraction hide the what abstraction does, it hides the complexity and lets you work with a complex system sitting behind that layer of abstraction, and only work with very few simple knobs, as I said, right? So in software engineering, if you visit a website, if you browse a website on the internet, it uses the HTTP protocol. If you send a mail, it uses the SMTP protocol, and all these things are possible because all the lower level complexity of taking care of network, taking care of how when you send email, it goes through the network, the physical wires, the servers, the DNS server lookup, and all those things are hidden behind an abstraction layer. And all you are doing is you are sitting in front of the browser and doing your work, and you don't have to worry about the low level complexity. So that's an example of abstraction. File system, if you use a file system on your laptop, you can see files and folders in a hierarchical format. There are 5 folders inside which there are other folders and files, but on the disk, on the physical disk of your laptop, that's not how the bits and bytes laid out. It's just that the abstraction layer of a file browser gives you a very simple way to work with those bits and bytes. Similarly, with software frameworks and higher level programming languages, they hide away a lot of complexity and lets you work with a simple, very simpler, far more simpler interface. If you think about abstraction, not just automobiles or software engineering, it's actually everywhere. Think of a large company, the CEO of a large company. What does he do? Does he really have to worry about every low level details happening? So let's say a CEO of a 10,000 strong company, is he aware of what's going on for all the thousands of software engineers working in his company? No, he's not. What he's doing is he's simply speaking to the top layer of management. So there are a set of VPs or maybe senior directors who he's directly working with, and these directors probably gather more data and then expose it to the CEO, and CEO looks at the information coming, the aggregate information coming from all these handful of senior people, and working with them, he is able to drive the whole organization efficiently and smoothly. So what has happened is all the complexity of the organizational work has been abstracted away for the CEO for a very simpler interface of the top layer of management. So abstraction. Now, very interesting, and I would say the trouble with all non-trivial abstraction is that at some point all abstractions either they fail big time or they fail small time. So when they fail, there is a very interesting term called leaking. So when the abstractions leak, and what do I mean by that? Going back to the example of the car. So when I drive my automatic car, as I said, I don't have to worry about shifting the gears. But let's say my car is on the third gear and I suddenly press the gas pedal. I want my car to speed up suddenly. So instead of speeding up by increasing the speed, what the car's automatic system does is it knows that it is at gear number 3, and it has to pick up the car very rapidly. So it will downshift the gear to gear number 2, then it will pick up, and then it will go to 3 and 4. So and so as a driver of an automatic car, ideally I should not be knowing what is going on underneath. I should not be knowing whether it's downshifting, upshifting. For me, if I press the gas pedal, the car should speed up. But actually what happens is car actually slows down for a few seconds, and then it starts going up, which means the details of what's going on behind my abstraction layer is slowly leaking up to me, which means I can feel that the gear shifting happening, which ideally should not happen. So the abstraction has leaked. Another example, in case of TCP/IP, like I said, that if I am working with a browser and I am loading a website, I am relying on the TCP protocol. It has abstracted away all the complexity, which means I should not have to worry about the lower level complexity. The higher level abstraction should work irrespective of what's going on at the lower level. But what happens if, let's say, the network wire is physically broken? Now that part cannot be taken care by TCP/IP or HTTP, because the physical link itself is broken. In that case, my work will stall, and I would have no way to know that, because the breakage, the disruption has happened at a layer which is beyond my abstraction layer. So again, the abstraction has failed, it has leaked. So another example of leaky abstraction. And that's the thing with all abstractions. At some situation, at some point under certain situations, they all leak. So abstractions save you time, but they save you time working, but they don't save you time learning. Because if you don't know what is about, if you have not learned about the complexity behind your abstraction layer, it won't help you in those corner cases when the abstraction starts leaking. And this happens very frequently. Let's say you start using a new software tool which helps you be more efficient and more productive at your work, and the veterans would often come to you and tell you that before you start using this new tool, this new framework, it's important that you learn to do it manually, and once you've done that a few times, then only you go and use this shiny new tool to save time. And the reason they say that precisely because when the abstraction leaks, you would at least know what might have gone wrong behind that tool. So that now brings me to how this idea is playing out in case of AI coding agents. So when the AI coding agents like Claude and Codex, when they burst into the scene, they promise that you don't really need to know any programming language. You don't need to be have any experience building software. All you need to know is speak English. So you sit with your coding agent you can just speak what you want to get done, and the coding agent will build the software for you, which works fine. People have been reporting to build vibe code, a lot of simple and even non-trivial web applications. But as we have learned that this AI coding agent is nothing but a layer of abstraction. It has enabled you to be able to build web applications or any kind of software applications without being aware of the underlying complexities, like you don't have to worry about knowing a programming language. You don't have to worry about the software design patterns which have to be used, or you don't have to worry about scaling, performance, and a host of other things which one is supposed to know to be able to build any non-trivial software application. But as your software application becomes bigger and bigger, soon you will hit a wall if you don't have experience or you don't have the knowledge of what goes into building software, what goes into what it does it take, what kind of mindset, or what kind of, if you've not built that knowledge base of really writing code, then when the abstraction leaks, which means when you hit a wall, you will you will be lost. You will know what you won't know what to do. And I have seen this happening a lot, that people, so I'll go back to the one to this specific quote, which says that abstractions help you save time, but they don't help you save time on learning, which means there is no running away from learning. You cannot defer understanding. If you're working with a piece of software, just because most of the code has been written by AI agent doesn't mean that you compromise with understanding the how different pieces in the software interact with each other, or how the whole software functions or works. So that's the thought I want to leave you with, that going by the principle of the law, or going by the law of leaky abstractions, the right way to use any AI coding agent is not to use it as a substitute for understanding, substitute for software engineering knowledge, and substitute of programming skills. It is just it should be used as an aid to make you more productive and efficient and save time, but it cannot save you from the hard work of learning the craft that is still required. Because if that's not there, when the abstractions leak, you will find yourself helpless.